6.6. Solve systems of linear inequalities. System of linear inequalities consists of two or more linear inequalities in the same variables, which we have here. Solution of a system of linear inequalities just means an ordered pair that is a solution of each inequality in the system. A solution for the above example could be 3, -6. For example, if I substitute 3 and -6 in, this would be 9. 9 greater than 7, so check, works. And for the other one, 2 times 3 is 6. And then we have a -6, so 6 minus 6 is 0, and that's less than 8. Works. The graph of a system of linear inequalities is just the graph of all solutions of the system. So to graph a system of linear inequalities, you need to graph each inequality. And then you need to find the intersection of the half planes. So the graph of the system is this intersection here. I'm going to show you an example right now. So I'm going to take x minus 1 greater than 7. I'm going to let that equal to 7 for now to find my boundary line. So my intercepts, I'm going to use intercepts to graph, will be 0, -7, and 7, 0. Okay, so since it's a greater than sign, I have to use a dashed line. So 7 could be, let's just make this a little bigger. Let's do 2s. 2, 4, 6, 8. So 7 is here. And then -2, 4, and then we plug this one, and then we could draw a dashed line. Okay, and then I'm going to have to shade in to use the 0, 0 test. 0 minus 0 is not greater than 7, so this graph does not include 0, 0 as a solution, so I need to shade this way, the other way. Okay, now I need to graph the other one. So I'm going to let 2x plus y equal to 8. And my x and y intercepts would be 0, 8 and 4, 8, 4 zeros. So 2, 4, 6, 8, and then 4 will go here. I can draw my graph. It's also a dashed line because it's a less than sign. Okay, and then I need to shade, let's see, 0, 2 times 0 is 0 plus 0, and then that's less than 8. So for this graph, we need to shade the side with 0, 0. So it's this side. And this part of will be all the solutions of this linear inequality, the system of linear inequalities. Guided practice. Part A. Tell whether the ordered pairs are solutions of the system of inequalities. So in order for these points to be the solutions of the system of inequalities, they need to satisfy both solutions of each inequality, meaning it needs to land within the shaded region, the points. And for 0, -1, it's here, and it's located on the dashed line, so it's not a solution. And 0, 1, located on the solid line, so it is a solution. -1, 0, it's located in the shaded region, so it's also a solution. And 1, 0 is located outside of the shaded region, so it's not a solution. Okay, and for part B, graph the system of inequalities. So for x greater than or equal to -2, I'm going to first graph the boundary line x equal to -2, which is here, and it's a solid line because it's greater than or equal to. And then we need to shade everything to the right hand side because it's greater than or equal, and we want all the x values greater than or equal to -2. And for the second one, we need to graph the boundary line y equal to 5, which is here, and then we need to do a dash line because it's a less than sign, and then we need to graph all the y values that are less than 5, so we need to shade it downwards. So the solution of the system of linear inequalities will be everything here, the intersection of both inequalities. Okay, so now we have the case where you have 3 inequalities as your system of inequalities. That's okay. Okay, we'll first graph the boundary line for y less than 4, which is y equal to 4. So that would be here, and then we need to make this a dashed line because it's a less than sign. And then we need to shade everything downwards because we want all the values, y values less than 4. And then we have to graph y equal to 1. So where's that? That would be here. Also a dashed line. Maybe I'll use red. And then it's greater than 1 for all the y values, so we need to shade upwards. And then we need to look at the last one. That's going to be y equal to -x plus 1 as your boundary line. So I'm going to use the slope-intercept form to graph. So my y-intercept is at 1. And I'm going to shift down 1 unit and 1 unit to the right. And then since it's a greater than or equal sign, I need to make a dashed line. Okay, I'm going to test my 0, 0 point. Let's see, 0, 0, plus 1, 0. So this is not true. So for this graph, 0, 0 is not a solution. So we need to shade to the right-hand side, this other half plane here. Okay, so our solution would just be the intersection of all 3 graphs. Maybe I'll use a better color here, orange maybe. Here. this part is the solution. Okay, for this one, we have a system of 4 inequalities. So let's take the first one and find the boundary line, x plus y equal to 4. So my x and y intercepts will be, when y is 0, x will be 4, and then when x is 0, y would also be 4. Okay, and let's use increments of 1, 1, 2, 3, 4, and 1, 2, 3, 4. And then it's going to be a dashed line. Okay, and then we're going to have to do a 0, 0 test. 0 plus 0 is less than 4, so we need to include 0 and shade in the left-hand side. It's half plane. Okay, and then let's look at the second one, x plus y equal to negative 2. When x is 0, y is negative 2. When y is 0, x is negative 2. So let's see. 0, negative 2 is here, and then negative 2, 0 is here. Okay, and then this is also a greater than sign, so we need a dashed line. And we need to see, let's see, 0, 0 test. 0 plus 0 is greater than negative 2, so we need to include the 0 and shade in the right-hand side of the graph. Okay, and then let's pick a different color. Let's use green. And let's see, x minus y equals to 3. And your x and y intercepts, when x is 0, y is negative 3, and when y is 0, then x is 3. So here we have 3, 0. Let's see, right here, and then negative 3, 0, 1. Then we're going to have to shade this in. Again, we need a solid line. Okay, and we test the zeros. 0 minus 0 is still 0, and then that is less than or equal to 3, so we need to shade in the top half of this graph. Okay, and let me use a different color. Let's pick blue, or no, we used blue already. How about yellow or black? Okay, so the last one, x minus y equal to negative 4. When x is 0, then y will be 4. When y is 0, x will be negative 4. So let's see. 0, 4. Okay, this point again, and then negative 4, 0 will be 1, 2, 3 right here. And then we're going to have to use a solid line because it's a greater than or equal sign. Okay, and then test the 0. 0 minus 0 is greater than or equal to negative 4, so we need to shade in the right-hand side of this graph. So as you can see, your solution is actually this part. Let me use a different color. Part C, write a system of inequalities for the shaded region. So first I'm going to look at the graph to the far right, and I'm going to use the slope-intercept form. Y equals mx plus b. Okay, and it seems like the y-intercept here is 4, so I can do y equals mx plus 4, and I'm going to substitute the point 40 in to find my slope. My slope will be -1, and so the boundary line here will be y equal to -x plus 4. And now I need to test the point 0, to see if it's a greater than or equal or less than or equal sign for this inequality. Y less than -x plus 4. And let's test this. 0, and 0 is less than or equal to 0 plus 4, which is just 4. So we would graph everything to the left-hand side of this boundary line, because it includes 0. And now we need to look at the other graph here. So y equal to mx plus 0, and 0 is your y-intercept. So then I need to find out my slope now. I'm going to use 1, -1. 1, -1 lies on the graph. So -1 equal to m. So your slope is -1. So your boundary line will be y equal to -x. And now I'm going to try y greater than or equal to -x. And I'm going to test the point 1, 1 to see if that's a solution. 1, 1. Yes, 1 is greater than or equal to -1. So my inequality for this graph here, this boundary line, okay, would be y greater than or equal to -x. Because if I were to shade it, it would be the other way, the right hand side of this graph, and your intersection would be the middle. So to find these are your solutions to this problem. The National Collegiate Athletic Association, known as NCAA, regulates the length of aluminum baseball bats used by college baseball teams. The NCAA states that the length in inches of the bat minus the weight of the bat cannot exceed 3. So we could represent that as length minus weight less than or equal to 3. And the bats can be purchased at lengths from 26 to 34 inches. So we can say the length is greater than or equal to 26, meaning it cannot be lower than 26, and the length has to be less than or equal to 34. And we can also say that the weight of the bats cannot be negative, so we can say W greater than or equal to 0. I'm going to write this to the side here. L equals the length, the bats. W equals the weight. Okay, so now we can graph all these 4 inequalities here. So for L minus W less than or equal to 3, I'm going to graph the boundary line. I'm going to let the x-axis be the length and the y-axis be the weight. So I'm going to find the L and W intercepts now. So when W is 0, L is 3. When L is 0, W is -3. Okay, so I'm going to set up my increments and tens, 10, and then 20, 30, 40. Okay, and then for the w-axis, I'm going to set up as 5s. Okay, so this will be -5. So when I graph this, 3, 0 will be here, and then 0, -3. Here I'm going to graph. And I have to shade this to the left because the 0, 0 test is true. 0 is less than or equal to 3. And we have to ignore the other part of this, the bottom part of this graph, because we only want to deal with the positive part. And then for L equals to 26, the boundary line, let me use a different color. It's about here. And I have to shade everything to the right, only in the quadrant 1. And when L equals to 34, I'm going to have to shade, well, let me first graph the boundary line. Shade everything to the left in the first quadrant. And for when W is equal to 0, I need to graph that. So this is the graph for W equal to 0, and I need to shade everything above. So my intersection here of all 4 inequalities would just be this part. Okay, and let's see what the last part of the problem wants us to do. A sporting goods store sells an aluminum bat that is 31 inches long and weighs 25 ounces. Use the graph in part B to determine if this bat can be used by a player on the NCAA team. Well, when this bat is 31 inches, then we need to plot that here. Okay, so 31 is about here. And then when 25 ounces, 5, 10, 15, 20, 25. So the point is about here. So this point does not lie in the the intersection area, the shaded region here. So we would say no. It doesn't satisfy the requirements. Okay, and this concludes our lesson.